Ever wondered how a building evolves from a mere concept into a tangible structure? Understanding the construction lifecycle is key to navigating the complex processes that transform a design into a completed building. From the early stages of land acquisition to project handover, each step involves intricate coordination among various stakeholders. With the integration of Building Information Modeling, or BIM, this process becomes more streamlined, improving collaboration, reducing errors, and enhancing project outcomes. In this article, we will walk you through each phase of the construction lifecycle and how BIM helps facilitate efficient project delivery. Land acquisition and initial surveying. The construction process begins with acquiring the land. This involves negotiations between a seller and a buyer, who may be an individual or a corporation. During this phase, the buyer must engage a title company, which is responsible for verifying the land's legal status. The title company ensures that there are no liens on the property and that the seller has the legal right to transfer ownership. Once the sale is agreed upon, the buyer typically commissions an ALTA, or American Land Title Association survey. This survey provides vital information, including property boundaries, easements, and public or private utilities running through the land. The ALTA survey includes three main components: records research, fieldwork, and the creation of a plat map. This ensures there are no surprises before the transfer of the deed. Project delivery and design phases. Once the land is secured, the owner must select a project delivery method. This could range from design bid build, where design and construction are handled separately, to design build, where a single entity oversees both aspects. Depending on the project complexity, owners may opt for a construction manager, or CM, to handle the entire process. After engaging an architect, the project moves through three critical design phases. Schematic design, which is roughly 50 to 75% complete, outlines the general layout and design intent. Design development, at around 75 to 90% complete, refines the project details, preparing for finalization. Construction documents, the completed 100% design, including detailed specifications, is submitted for bidding by contractors. The role of BIM in design and coordination. Building Information Modeling, or BIM, plays a transformative role in the design and coordination process. At its core, BIM is a digital representation of the building's physical and functional characteristics. It allows all stakeholders, architects, engineers, contractors, and owners to collaborate using a shared 3D model. BIM's impact is particularly evident during design development. In traditional construction, miscommunications and errors between trades can lead to costly rework. However, with BIM coordination, potential clashes between building systems like HVAC, plumbing, and electrical are detected early, allowing for adjustments before construction begins. This improves both efficiency and accuracy, reducing the risk of errors during the build phase. Pre-construction phase. Before construction can begin, additional groundwork is required. Geotechnical surveys are performed to evaluate the soil's suitability for supporting the future structure. This step involves soil borings and lab tests to determine whether the site can handle the building's weight and prevent issues like sinking or structural failure. Once the geotechnical report is complete, the owner solicits bids from general contractors, GC, or construction managers, CM. These professionals oversee the execution of the construction project, but often hire specialized subcontractors to complete various aspects of the build. In this phase, estimators, project managers, and schedulers work together to provide the owner with a comprehensive proposal. Simultaneously, the project must secure necessary permits from local authorities. These permits ensure the design complies with building codes, zoning regulations, and environmental standards. Permit approvals mark the conclusion of the pre-construction phase. Construction phase. The actual construction process typically starts with mass grading and site preparation. This includes clearing the land, leveling it according to the civil plans, and installing underground utilities such as water, sewage, and stormwater systems. Once the land is prepared, the foundation work begins. Foundation and structural work. The foundation is laid using concrete and reinforced steel, or rebar, to provide the building with stability. Afterward, contractors build structural walls and begin framing the building. Framing and utilities installation, electrical, plumbing, and HVAC systems are installed according to the BIM coordinated plans. Since these systems need to be laid out before walls are closed up, BIM ensures that pipes and conduits are properly routed, avoiding costly errors. Roofing and enclosure. The building's exterior is completed next to protect the structure from the elements. This allows interior work, such as installing drywall and ceilings, to proceed without risk of weather damage. Throughout the construction phase, regular inspections are carried out to ensure compliance with building codes. These inspections are crucial for maintaining the integrity of the project and for progressing to subsequent construction stages. The critical role of BIM in construction management. During construction, BIM serves as a real-time tool for tracking progress, managing resources, and coordinating subcontractors. Here are some key ways BIM enhances the construction process. Real-time coordination. By using BIM, project teams can view the construction model in real time, identifying potential conflicts before they occur. This minimizes disruptions and ensures that the project remains on schedule. Quality control. BIM allows architects and construction managers to compare the actual build against the design specifications. This helps identify deviations from the plan and ensures that corrective actions are taken immediately. Resource management. BIM facilitates the management of materials and labor by forecasting needs and optimizing resource allocation based on project timelines. Finishing touches and occupancy. As construction nears completion, the focus shifts to the building's interior. Contractors install drywall, doors, finishes, and fixtures. Mechanical, electrical, and plumbing (MEP) contractors ensure that all systems are functioning as intended. Before these areas are closed up, final inspections are conducted. Once all inspections are passed, the project moves toward final approvals. The contractor and the owner conduct a final walkthrough, during which they identify any incomplete or non-conforming work, known as the punch list. Addressing these items is the last step before receiving the occupancy permit, which certifies that the building is safe and ready for use. Project closeout and handover. The project closeout phase involves final documentation and handover to the building owner. One critical element in this phase is the BIM as-built model, which contains a digital record of the building as constructed. This model is invaluable for the owner's facility management team, providing them with detailed information on the building's systems and components. Additionally, the contractor provides the owner with operation and maintenance (O&M) manuals. These manuals include training on the building's systems, ensuring the owner can manage the property efficiently. At this point, final payments are made, and the project is officially handed over. How BIM enhances the construction lifecycle. BIM is a game changer throughout the entire construction lifecycle. From initial design coordination to final handover, BIM helps ensure that all stakeholders are working from the same information, reducing errors and improving project outcomes. Enhanced collaboration. BIM fosters collaboration between architects, engineers, and contractors by providing a central source of truth. Reduced errors. BIM allows teams to identify design clashes early, saving time and money on rework. Improved facility management. The BIM model serves as a long-term resource for managing the building post-construction, streamlining maintenance and renovations. Key takeaways. From land acquisition to project closeout, the construction lifecycle is a complex journey involving numerous steps and stakeholders. However, with BIM at the forefront, this process becomes more efficient, with better coordination and fewer mistakes. As the construction industry continues to evolve, BIM is leading the way in improving how we design, build, and manage our built environment. BIM integration improves coordination. Building information modeling (BIM) plays a crucial role in facilitating communication and collaboration between stakeholders, helping to identify and resolve design clashes early in the construction process. Land acquisition requires thorough legal and surveying processes. The construction lifecycle begins with land acquisition, involving legal verification, title clearance, and detailed surveys like the ALTA survey to assess boundaries, easements, and utilities. Phase design process. The project's design progresses through schematic design, design development, and final construction documents, ensuring all elements of the building are carefully planned before construction starts. Pre-construction planning is crucial for success. Securing permits, selecting contractors, and performing geotechnical surveys are essential pre-construction activities that ensure the project is ready to proceed without major obstacles. BIM enhances project tracking and quality control. During construction, BIM models help monitor progress, manage resources, and ensure quality by comparing the build to the design specifications in real time. Inspections and approvals are continuous throughout the construction lifecycle. Regular inspections are required at each major phase to ensure the project adheres to local building codes and safety regulations. The punch list and handover complete the project. Before final handover, a punch list of incomplete or non-conforming work is addressed, and the final BIM model is delivered to the owner for long-term building management. BIM provides long-term value. Beyond construction, the BIM model serves as a valuable resource for facility management, ensuring the building is efficiently maintained throughout its life cycle.